sketching squared functions. So here we'll be looking at taking a graph y equals f of x and sketching y equals f of x all squared. And some things to note is that 0 squared is just 0, 1 squared is 1, a value in between 0 and 1, let's say 0.9 squared, is going to give us 0.81, so it's going to be less than the original value. Something a bit bigger than 1, 1.2 squared, is just going to be 1.44. So that's a value bigger than the original value, which makes sense because 3 squared is 9. So taking a value bigger than 1 and squaring it gives you an even bigger value. And obviously, squaring a negative number gives us a positive number. So all these things are going to help us when we go ahead and sketch some of these curves. So the first thing we're going to look at is we're going to look at y equals cos x. And we want to graph y equals cos squared x, or cos x all squared. So let's graph the original cos x. So starting at 1 and doing this. And we've just graphed from 2 pi and minus 2 pi. And obviously we know it's going up to 1 and down to -1. Okay, some important things to note is that when cos x equals 0, so wherever it's on the x-axis, they're all the y values, where y is equal to 0. We know our graph is also going through there because 0 squared is also 0. Wherever the curve is equal to 1, so up here, here, and here, we know 1 squared is also equal to 1, so we know our curve is also going through those points there as well. And in fact, whenever y is -1, -1 squared is 1. So whenever y is -1, our curve will also be 1. So we know it's going through all of those points so far. All of these y values are in between 0 and 1. And we know when we have a y value in between 0 and 1 and square it, we get a number smaller than the original number. So that means in this portion here of the graph, our function needs to be below the original function. So we're going to get something, we're going to get something like this. And then all of these negative values, squaring them, give us positive values, which makes sense because we know it has to come back up to here. So we're probably expecting something like that. And this is just going to repeat itself. So below, negative values becoming positive, 1 squared being 1, negative values becoming positive, 0 squared being 0, value smaller than the original, and 1 squared being 1. And that's what we're going to get for y equals cos squared x. Let's have a look at one more example. Y equals x squared minus 2x. And then we're going to want to graph this function squared. So it's going to be x squared minus 2x whole squared. So let's draw our original function first. So we know we can factorize this to get x outside of x minus 2, which is going to tell us our intercepts are at 0 and 2. And it's going to be concave up because x squared is positive. And now we want to graph this function squared. So we're going to note the 0 squared is also 0, so our curve must go through those 2 points. We actually have our vertex here at 1, at x equals 1, and we can get the y value. So we just sub in x equals 1 and we get 1 squared minus 2, which is minus 1. That's going to be important because the y value there is minus 1 and minus 1 squared is 1. So we know this is going to be going through 1. All of these values are in between 0 and minus 1, which means when we square them, we're getting even smaller numbers. And same with these values, these initial values here, up until we get to 1. When we square them, we're getting smaller values, so we need to be below the curve. But once we get past 1, we start getting bigger values. So it needs to start going above the curve. And the same thing will happen over here. Until we get past 1, that's when the values start going above the curve. Which means our graph also needs to hit this point up here, and we're going to get something like that for our original function squared graph.